Greetings everyone. I'm Shambhu Pruthroy on the behalf of Nilgiri House Statistics Community, earlier known as Chi-Square Statistics Club. I'm delighted to welcome you all to today's session, Understanding and Applying Statistics, Real Life Uses and Research Pathways. Today we are honored to have Mr. Prashant Sharma with us, our guest speaker for the day. Many of you know him as the course instructor of Statistics 1 and 2. Beyond classroom and lectures, he brings a wealth of knowledge and practical insight into the world of statistics. Shaped by his studies at Delhi University and his passion for making statistical thinking accessible and impactful. Today's talk will be a bridge between theory and application, helping us see how statistics shapes the decision making, fuels research, and solves real world problems. I encourage you all to listen closely, take notes, and interact because sessions like this are opportunities to go beyond the syllabus and connect learning to life. Also, I have all your queries you had submitted earlier, and I hope that will be answered over here. So, without any further delay, please join me in welcoming Mr. Prashant Sharma. Sir, over to you.
Many of you are from foundational level, or first of all, how many of you are in foundational level? Okay, you can raise hand. Maybe I will get some idea. Okay, some 9, 10. Oh, okay, most of us. Are you in second term or first term only? Second term?
First one.
First term. Okay. And how many of you are in diploma level? Okay. And what about degree? Okay, very few are in degree level, correct?
Yeah.
Okay, no problem. Okay, so today's session is just all about whatever the things you have learned in the statistics course, basically. So we'll quickly go through some of the uh, topic and I mean the practical uses of those topics in real life and what are the possible research pathway you can apply. So those are just example. It's not like you have to do in that way, but maybe that will create a bridge between that statistics theory what you have learned uh, and with the real life situation. Okay, so let me share my screen and I received some of the queries from your end. So after the end of the session, I will try to answer of those questions. Okay. Okay. All right. So let me share my screen. Uh, can you see my screen?
Yes, sir.
Okay.
It's visible.
So hello everyone. So myself Prashant Sharma. So I'm course instructor in this BS degree of statistics courses. Okay. So today is just about 3 sections. So we'll do some introduction and main content and conclusion part. Okay. So first of all, I would like to hear from you guys. So what is statistics? What's your thought on statistics? Anyone, feel free to answer. Yeah, please go ahead. Summarize that.
Sir, the art of understanding the data and then making inferences about the data.
Okay, correct. Anybody else? Feel free to say. Say, don't, whatever the things is coming in your mind, you can say. Okay, so this is not any uh, session, something like that. You will give wrong answer and you will get some penalty. Okay, so whatever the things, so it's just it should be more inclined to discussion part. Okay, so I can see chat summary of data. Okay, anybody else?
So stats is like in general, it is a study of data. If you go
Okay,
in specific, you can like split it into either just summarizing data or using probability to model
Mhm.
data,
Mhm.
making conclusions from the data, or like using data to find what next steps anybody should take based on that. So
Okay, correct. Anybody else? So suppose I'm saying statistics. What is, if you want to explain to someone what is statistics, then how will you start? Yeah, please go ahead, Premanand.
So statistics is uh, tool us data sets and there are insights from them and use those insights to like to get actual value from in real world.
Okay. Okay. Anybody else would like to answer? Okay. So basically, see, statistics. If you see, some people think this is just numbers in some textbook or formula in a textbook. Okay. So statistics is not all about just a number. Okay. Or some collection of complicated formulas in a textbook, or so it's all about what's your understanding, like regarding data and how you are, basically it's about decision making under uncertainty, right? So there is not something 100% certainty always, right? So you, this statistics will give you the idea how you can make decision, right, under uncertainty. Okay, so for example, I took very IPL example. Okay, suppose today is IPL final day and pitch is dry, and let's say Chennai is batting first. Okay, so your model may predict, okay, there is 63% chance of winning Chennai. How? Okay. So that's the statistics, right? So basically, you are making decisions under uncertainty. Okay, so so statistics is not all about just a number. You have some number and you have some formula, variance formula, some base theorem formula, complicated. Those formulas are there. Those formulas plays a very important role, but it's very practicable also. For example, suppose you are an analyst. Okay, so then before the match even going to begin, you already know what is the probability of winning if we bat first, or bowler has the best economy, and etc., right? So these all are statistics. These are all, it's not about just a number in textbook and all. Okay, so one question to all, for all of you: how many of you have used statistics today without even realizing it? Can you tell me if you have used it somewhere? Any single example? No one? Okay. Did you get my question? So this is my question. How many of you have used statistics today? Let's say today or day before yesterday, whatever. I'm talking about in terms of daily. Yes, yes, Samyabrata, please.
Today, after waking up, by looking at the sea, I estimated the weather of today and decided to go for work or not.
Okay, correct. Basically, weather apps. Yeah. Anybody else? So see, most of the time, yes, predictive whether today would be productive or not. Okay, how will you predict? Okay, all right. See, most of the time you have done it, but we didn't notice. For example, that Somaprata says this weather part, right? So you woke up and you saw the weather app, right? Whether it's forecasting for rain or temperature. So this happens based on the time series analysis and some predictive models. So we are not going to that much depth. So I'm just giving you the idea basically. So suppose that app shows there is a 60% chance of rain today, right? So this is something you are using daily. So for example, online shopping recommendation, right? So this Amazon, Flipkart, Myntra, etc., right? So these suggest products, which products you have to buy and all. So this happens under the something called collaborative filtering and statistical similarity measures. Okay, so basically you can see the every recommendation is based on analyzing the patterns of the million of users. So again, this analyzing patterns from million of users, so this will give you the data. So based on this data, they are analyzing the patterns and they are giving you the recommendation and all. Okay, so this is something we are using on daily basis. Some of you doing the selection for which restaurants I should go or not. So this happens based on the ratings only, right? Which comes under the something called concept descriptive statistics. We'll see this concept as well. Okay. So your phone's autocorrect features, right? So that features you already. So that comes under the predictive model. So you can see these all are examples. This is something you are using daily, but you didn't notice. Okay, what about suppose I'm saying, uh, for example, suppose I'm writing one statement. You to tell me how to. Suppose if I told you there is a 90% chance, okay, you will have a coffee today. Okay, so how many of you would agree with me, and why? I mean, why? I mean, how I can say this? Is there any reasoning behind it? Suppose I'm saying 90, there is a 90% chance you will have a coffee today. What concept I can apply here? Which concept?
So it would be like there would be maybe a model of some kind where like I know that every day like this is if I've recorded for say 100 days and
Correct,
like out of those 100 days 90 days I've had coffee.
correct,
That's a
correct,
very
correct,
simple example, but
correct,
like
correct.
I can say that there's 90% chance.
Yeah, absolutely correct. So basically, this that's basically how your probability works here. So it's just a prediction based on your past data, right? As he said, you observe something for 100 days and you identify out of those 100 days, you are going 90 like for 90 days, something like this. So there is a 90% chance you will have a coffee today. So you can see, so there are lots of things we are using. Even we are not noticing, right? We are not something, it's not in our notice, but we are using. So this statistics is not about just okay, so we saw the formula x bar over 1 upon n summation xi, we saw x1 x2 some 1 2 3 4 5, and we added and we divided by 5, we got 3. Okay, so that's all. So no, it's not all about formula and all. It's just something, uh, there are lots of practical aspects of this statistics actually. So very first thing I would like to start, maybe if you guys have done this stats 1 and 2, then so basically statistics, most of you told me, it's just it's basic science of collecting, organizing, analyzing, and interpreting the data to make the decisions, right? So whatever the decisions, so you can say in this example, one decision I made, okay, there is a 90% chance you will have a coffee today. So how it is? So there was a collection of data for, let's say, last 100 days or some 2 weeks or 3 weeks, and we calculated the probability from the past data, and then we interpret that data and we made a decision. Okay, there is a 90% chance you will have a coffee today or something. If you see this example, there is a 60% chance of rain, or there is a some 70% chance of that Chennai is going to win the match, something like that. So it's all about basically making decisions under uncertainty. Okay, so there is two main branches of statistics. So first one is called descriptive and another is called inferential. So descriptive is all about how you are summarizing or describing your data. Okay. So summarizing and describing your data means, suppose you have a data of some, let's say 50 rows. Okay. And it's all about age of something. You can calculate the average and you can calculate the median, you can calculate the mode. So you are calculating these measures and you are summarizing those data set in a single number. You can define what is the variability, and if you want to, okay, so nowadays this visualization tools are very helpful. Okay, so rather than giving numbers, you can make a bar chart, you can make a histogram, you can make a box plot and all. Okay, so this descriptive statistics is, it's all about how you, whatever the data is having with you, how you are summarizing. So for example, So during COVID-19, right? So descriptive statistics plays a role daily basis. So daily basis means how you are summarizing the data, like what are the total number of cases, what is the recovery rates, what is the positivity rates, something to communicate with the people. So are you getting idea this descriptive statistics? So whatever the data you have you are summarizing and describing that data. So you can see the how this is helpful in real life data. Also, you are making this decision for restaurant selection. So you saw so based on the ratings, this ratings is what? So this describes the data of ratings, and then based on that you are selecting. Okay, so this is the restaurant I will go for dinner today, something like that. Okay, so next one is inferential statistics. So as you see the term inferential, so you are trying to make an inference about population data. So population is a large data set, okay, and you are making the conclusion, you are making the inference based on a sample data. So for example, you want to uh, you want to make the inference about what is the average marks of class 10th students all over the India. Okay, then what you can do, you are not going to collect uh, all those students who are doing their 10th, right, all over the India. What you will do, you will select a sample, and based on those samples, suppose you calculated the average marks and you got, let's say, 80 82. Okay, then you are making a conclusion, you are drawing a conclusion, you are making a inference about the population for all over the India, students of all over the India. Okay, average marks is 82. Okay, so this is something inferential statistics. Also, you have seen the hypothesis testing, right? So in hypothesis testing, what we are doing, so there is a claim. Okay, suppose you are a there is a manufacturer of a company, and in the company they are manufacturing some medicine bottles and all. So there is a claim from the manufacturer. Okay, on an average there is, let's say, some 100 ml liquid in the bottle. So that this claim made by the manufacturer. As an analyst, you had some doubt on that claim. You collected some sample data, you did your hypothesis testing procedure, and then you saw, okay, you made the conclusion, okay, no, this is not true, or this is true, something like that. Okay, so another example here, you can see this in terms of business like I mean this Flipkart and Amazon. So they track the average order value, most purchased categories and all. Okay, so these all things are very helpful in marketing decisions and all. So if you see for, okay, tell me which one is, this one is for descriptive, or this one is for, which one is for descriptive and which one is for inferential?
Second is inferential, sir.
Second is inferential.
Yes.
Okay, what about third one?
Sorry, sir. The third point overall is like from what you've ticked, the second is inferential. So the third point is inferential. Sample of
Oh,
voters.
okay, understood, understood. What about this one?
That is descriptive, sir.
That is descriptive, right? Okay, so if you see this election exit poll, so what they are doing, so they are using a sample of voters, right, to predict the final result. They are not using the all the data, right? So whenever there is a small data set, sample data set, a sub part of your population, and you are making conclusion based on that sample data, that comes under the inferential statistics. So these two branches, this descriptive statistics and inferential statistics, they are these are the key two main branches of statistics. They plays very important role of any data set. So whatever the data set you have, you are giving the summary, you are describing that data set, right? And there are lots of measures, so mean, median, mode. So based on the objective, you can use whatever the things you want, and to check the variability and all, there is variance, standard deviation, and other kind of measures. And there are visualization tools also, right? And inferential is something you are making conclusions for your population data based on your sample data. Okay, so is this okay to all of you? Are you getting something? Or I hope most of you know already. Yes, no? Okay, all right. So the thing is there, see, these are just examples. So this is not necessary. Okay, so these are just examples. So basically, how you can use this two things in research path is basically you can design better ways to summarize big data in real time dashboard. Okay, and then basically you can, okay, any one of you can give me example for this first one. What I mean by design better ways to summarize big data in real life dashboards. Any example?
So it could either be coming up with like good measures of like
Hmm.
descriptive statistic measures.
Hmm.
It could also be coming up with more efficient ways to work with big data because summarizing big data,
Correct. Yes.
those.
Yeah.
Sir, in one of the lectures, Andrew sir said that if the experiment is very big, then we can start
Hmm.
defining many random variables and then start summarizing those random variables.
Okay. So my question is this: how you can design a better ways to summarize big data in real life dashboard, real time dashboard? No. Okay. No. I mean, you are not able to think, or yeah, I'm waiting for your answer. Whatever the things it's coming in your mind, you can feel free to say.
Optimizing existing tools to summarize big data.
Correct. 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 Yeah. So see, and basically, though, yeah, correct answer. And the next one, basically, how you can, so see, there are lots of ways how you can summarize the data, right? There are lots of techniques how you can summarize your data. So the thing is, you can do research, or you can go ahead with how you can design a better ways, right? So there are lots of ways already it's existing. We are doing lots of statistical analysis in today's world, but how you can design a better ways to summarize some big data in real time dashboards. So real time dashboards is something, let's say, some this, let's say this temperature example also, or in basically you can say in rural areas, people, so there are very less percentage of literacy, right? So you can, how you can make real time dashboards is, for suppose there are farmers, okay, how you can make some better ways, or some better dashboard. So based on the past data, or based on the, and including the current time. So suppose there is a month of July, and farmers can get to know, okay, so there is heavy rain or something like that, and accordingly they can plan. Okay, so something, some big data. Okay, so for Indian population also. And along with that, you can start work on data visualization for methods for low literacy audience in rural India. Okay, as I told, for this farmers and all. And there is something survey sampling methods. Okay, so how you can optimize the sampling sample sizes, how can you can reduce the biases and all. Okay, and for these kind of things, there are some Indian research bodies. So some one thing called NSSO, so it's National Sample Survey Office. So, and next one is most of the people, you know, this Indian Statistical Institute. Okay, so these are just examples uh, you can think of applying the concepts, whatever the thing, this descriptive and inferential part of this. Okay, so the next thing is again this probability. Okay, so probability is all about, I mean, we are using, and most of the people, you are solving so many questions and all, you are giving the quizzes. Okay, so probability is basically how you can quantify uncertainty. Okay, so there is something uncertainty. Okay, so basically what does this mean? Basically, so the likelihood that an event will occur. So what is the probability? What is the chance that an event will occur? What is the chance that tomorrow there will be rain tomorrow. Okay, so for example, suppose a team needs 40 runs from 20 balls with 5 and there are just a 5 wicket. Okay? So you can make a model, right? So that model based on your historical matches, I mean previous matches, they might say, okay, so there is a 65% chance of winning. Okay, what is this? This is probability. So what you are doing, you are so quantifying the uncertainty, right? So what is this part here? So whether this team may win the match or may lose the match. All right. So what you are doing, you are quantifying those things, those uncertainty, that chance in a number. Okay. And what are the real life uses? So first of all, this cricket part we are saying, so win probability models you can make in agriculture. So this IMD's rainfall prediction models, they use the probability to warn farmers. And in finance also, the banks uses a probability models to calculate the chance of loan default, whether there is a loan default or not. Okay. And in terms of this specific part, probability, so what may be the this research pathway? So you can improve the probabilistic forecasting for localized weather in rural areas, and we have seen this Bayesian things, right? So you can see how to apply this Bayesian probability to medical diagnosis and all. And then next one is something risk modeling for agriculture, crop insurance. Okay, so this is huge in India due to climate uncertainty. You can say nowadays there is uncertainty in climate. Okay, so is this okay? So far so good. Is there any? Are you getting? Are you able to relate this things, concept and okay? All right. So I can see some of thumbs up. Okay, all right. So this next one is something called hypothesis testing. Okay, so we are not going into too much deep. I'm just giving you the some rough idea how you can apply these things. So what we are doing while we are in term or you are doing the course. So basically, our focus is just all about, okay, so this is the syllabus. I have to somehow grasp the formulas, and I have to know. I should know how to solve the question. I mean, basically, we are not going into the practical life where I can use this kind of thing. So I'm just giving you some rough ideas. So if you feel we can have a deep discussion for any of the topic in upcoming sessions if you want. Okay, so anyway, so the hypothesis testing just a method, so basically method to decide whether there is enough evidence to support a claim using sample data or not. Okay, so the claim, okay, for example, there is a company that claims their average delivery time is 30 minutes. Okay, and you as suppose as an analyst, you suspect, okay, this claim doesn't seem correct. So what you will do, you collected a sample of 50 delivery times, and you use your hypothesis testing to check whether the claim holds or not. Okay, so you will see whether, okay, so you might think, okay, so this, okay, suppose this is average. So what you will do, your okay, so the company's hypothesis is nothing but mu is equal to 30. Mu represents the population mean. Okay, so what you may test, okay, so this may be more than 30 minutes. So what you will do, you will collect a sample of 50 I mean, this is just sample of 50 delivery times, and you will perform the procedures of hypothesis testing, and at the end you will find out, okay, so this claim holds true, this claim doesn't hold true, something like that. Okay, another example is, you can see here, so whether does a new fertilizer increase yield or not. Okay, suppose there is a company, and so they produces new fertilizer, and you have to check whether that new fertilizer increase yield or not. Okay, so what will be null hypothesis? No difference. What will be the alternative hypothesis? Okay, so there is increase in yield, and you will do some samples collection, and you will perform your hypothesis testing procedure, and then you will see, okay, this is done. Okay, so what are the real life uses? So again, you can say these are the real life examples. So in real life, how we are using basically, so you can say in the pharma sector, so they are testing whether a new medicine is more effective than the standard one or not. Okay, that might be one of the real life uses. In education, they are evaluating, okay, so there is if a new teaching method improves the exam score in rural schools or not. Okay, so in rural schools, there is very I mean, there is not good things about education, at least in few schools. So so how you can check, okay, so there is a new method, new teaching method, whether this improves the exam scores or not. Okay, and in manufacturing field, actually, you will say, okay, so if the defects rates are below the acceptable limits or not. So this acceptable limits and all we can see later. Okay, so this is something. So the key idea about hypothesis testing is, so there is a claim. Okay, what you have to do based on sample data, you are going to test, okay, that claim is true or not. Okay, so there is a claim is basically there is a hypothesis, and based on sample data you will check whether this hypothesis is true, or whether you are going to accept the hypothesis, or whether you are going to reject the hypothesis. Okay, so in terms of hypothesis testing, so in research pathway, so I took I took only one example, something called biostatistics and public health. Okay, and the institutes you can check for this: ICMR, AIMS, and National Institutes of Epidemiology. So, okay, any one of you, can you tell me what problem you can define, or you can take, or you want to check, you want to test for this biostatistics and public health? What are the possible ways you can? Anyone? If I'm giving you title like this, so what problem you can define?
Antibiotic resistance in general public.
Okay. Or anybody else?
Maybe like outbreak of any disease.
Okay. Anybody else?
Predicting mosquito population in a particular area and trying to prevent it.
Okay. Yeah, I'm getting new ideas. What about others? Nobody?
Sir, how genetically resistant to how much genetically resistant a population is to a particular disease or virus?
Yeah. And see, there are other things also. So you can see vaccine effectiveness yesterday, right? And you can go with the air pollution and asthma research also. See, vaccine effectiveness, for the vaccine effectiveness. So in public health, so what you can do, you can define the population, and you can some recruit participants, and you can monitor side effects and all, right? And so basically in biostatistics, what it will do, it will estimate the vaccine efficacy, right? And then you will adjust for, okay, so you can adjust for the age and all. Okay, so okay, so suppose there is a vaccine. Okay, so you can take example of COVID-19 also, right? Something like that. So in biostatistics, what they are doing, so it's basically application of your statistical methods. Okay, so in terms of biological or medical or health related problems always. Okay, so this is basically a toolkit. It's a toolkit. So okay, so let's say for vaccine effectiveness. Okay, based on that you can decide, okay, so this vaccine is applicable for let's say the person who are after, I mean, more than 20 years, and this kind of vaccine is applicable for no, for infant child or something like that. Okay, so this is something, this is just an idea. I mean, this hypothesis testing is how it's helpful in biostatistics and public health. Okay, so these institutes are doing lots of hypothesis testing for this in terms of this biostatistics field, and in terms of public health as well. Okay, it's all right. Okay, see some chat. Not able to think. Okay. Okay, so the next thing is something called regression analysis. So most of people, I think you have already used, but let me go through one. So what is the regression analysis? Anyone?
It's finding a linear relationship, or it's using a linear function or non-linear function
Mhm.
where you can assign like weights to particular independent variables.
Okay,
Using that, you can predict the value of the dependent variable.
dependent variable, correct. So basically there is some variable, it's called response variable or dependent variable. So regression analysis, what it does actually? So regression is just it's a statistical method so for understanding the relationship between two variables, okay, and then you are making the predictions. So for example, the very simple example for house price, most of the people know. So house price is, let's say I'm denoting as a yi, okay. There is a one term called intercept, and then you can define beta 1, and what will be the another variable which will affect the house price? Let's say I'm writing here beta naught. Okay, so this is just a regression model I'm writing. So house price is beta naught plus, let's say, beta 1 x1 plus beta 2 x2 and some random. So what might be x1? How what are the things can affect the house price?
Area, number of bedrooms, or
Number of bedrooms, right? Area of the house. So okay, and also you can define others variables. Okay, so like distance from metro, distance from hospital. Based on those things, house price also affected, right? And see, whenever you will do all these things in real life situations, so there always be some lots of independent variables. Okay, so there will be some variables, and then sometimes you have to think about, okay, so there is, I mean, you have to exclude some variables from your things, and there might be some variables which are I mean, they are related to each other. I mean, you may find x1 and x2 are related to each other. That is something called multicollinearity. We are not discussing that, but I'm just giving you idea. Okay, so basically what we are doing in regression analysis, so we are understanding the relationship between the two variables, and then we are making the prediction. So basically this prediction price, okay, which yield from rainfall. Okay, so predicting, sorry, not price, prediction rice yield. Okay, so this rice yield you can define as a y from rainfall, temperature, and what are the fertilizers farmer has been used. Okay, so this is something you can say. You are making you are understanding the relationship between the variables, and after that, at the end, you can make the prediction about this. Okay, so what are the real life uses of this regression analysis? So in economics field, okay, so they are predicting inflation from the interest rates, fuel prices, and other different of indicators. As I took example of agriculture, so in agriculture field, so they are estimating the crop yield from rainfall, fertilizer use, and soil type and all. And in e-commerce area, actually, you can see, so in e-commerce they are predicting the sales from advertising spend and all. So first of all, why it matters, this regression analysis? So basically it will help you in identifying which factors matter most and allows the future prediction. Okay, so as you can see in house price prediction, so sometimes you will find, okay, this factor is not that much important, I shouldn't include in our in my analysis, I can exclude something like that. So that those kind of feature selection and all, it's other discussion, but it will help you to identify this regression analysis. Okay, so these coefficients and all plays a very important role. Okay, so what are the possible research pathways actually? So first of all, you can use the regression models for precision agriculture things, and then something called time series regression, and you can apply this time series regression to forecast, okay, renewable energy output, basically renewable energy output in your India. So this regression analysis is very helpful actually. This, so whenever I think most of people, if you have done this diploma courses, and then you have seen this something, this regression and all in ML courses also. So this regression, all things is also very helpful in to understand the ML courses. Okay, basically this is something real life uses. Okay, so can you tell me how e-commerce they can predict the sales or something like that? Is there any regression you can apply? Any technique? Or let's say Swiggy company itself, right? So they are advertising something, right? For example, you ordered something and it will show you, okay, so your order will be delivered in 30 minutes. So what are the what is the way or what is the technique they are applying?
So, sir, for that prediction of like 30 minutes itself, it's probably a regression algorithm of some kind.
Yeah, correct. That's what I'm trying to.
So they'll be using like distance from like the restaurant to your location.
Correct. Yeah,
This is like delivery partner from the restaurant.
correct.
How much time it'll take the restaurant to actually prepare like the food.
Correct. Yeah,
And like traffic and all, if the algorithm is very good, then they'll
very
increase
good. Yeah,
that.
yeah, that's correct. Very good. Yeah, so you can see it's all over. I mean, see, around us, statistics is there. Without statistics, it's very difficult. Okay, all right. So next thing is called next thing I took as I thought I should discuss, which is called sampling. I think it's not in our uh, DS course, but what is the sampling? Actually, it's just lots of techniques. Okay, so we are selecting a subset of a population, which is called sample, to make inferences without surveying anyone, without surveying everyone, not anyone. So everyone means you are not going to each units of the population. You are taking a subset of the population, and based on that, you are making inferences. The thing is how you can make how you can do those sampling, right? So there are lots of sampling techniques based on your objective, based on your project or something like that. You can define how to you have to decide which sampling techniques you have to use. Okay, so what is the real life uses actually? So this exit polls in elections, so they use a stratified sampling to predict the result. So stratified sampling is one of the technique. Okay, so in stratified sampling, I will give you just a rough idea. So in what we are doing, suppose you have a population of capital N, and then you are making something called stratas. Okay, so basically you can say you are dividing this N such that, suppose here it's N1 person, N2 person, and N3, and let's say Nk. You made some K boxes, something like that, and within each boxes you are keeping the people with some criteria. Let's say here you kept the people for different region or differences. So basically this strata, it's called strata. So this strata will be you have to make as much homogeneous you can. I mean the units inside this particular category, that should be approximately, the characteristics of all the units should be approximately same. And then what you are doing, you are selecting a sample of N1 here, small N2 here, small N3 here, and let's say Nk here, and let's say you are adding all this, and nice, you got a sample size of small, and you are performing the things of on this sample size. Okay, so this is one of the technique. Next is census survey. So this NSSO, right? This National Sample Survey Office. So they collect the data from samples to estimate the unemployment rate. So this is one of the tasks of the NSSO. There is something called one of the uses is quality control. So in quality control, what they're, so factories inspect a sample of products for defects. Okay, so basically defects means, suppose there is a company which is making chalk, right? So what you will do, you're not going to check all the chalk, right, whether it's of good quality or not. You will take a sample, you will do your testing, and you will decide whether that I mean that things you have to purchase, or you want to purchase or not. And why it matters, basically it saves your time and cost, and it makes large scale data collection possible. Okay, first of all I will try to give you one idea. I have a rough sheet about this sampling actually. So why this is important, actually there is something called purposive sampling. Okay, maybe this will give you the idea what is this purposive sampling. So there are lots of techniques actually. So this purposive sampling, what it does, okay, So okay, suppose there is an analyst or there is some person, okay, who want to do some analysis. What they did, and they want to check whether the standard of living has increased, okay, let's say in Delhi or not, for example. Okay, suppose this is your objective. Then what that analysis did, they took samples from the rich locality only. Okay, so in Delhi there are lots of rich locality called South Extension, so and Defense Colony and all. So what they did, they took the samples from the rich locality and they took the data of, let's say, annual income of the people from rich locality only, and at the last they made a conclusion. Okay, so the standard of living has been increased in Delhi. Okay, so is this good inference, good conclusion, or is this sample is good one or not? What's your thought?
Not a good sample, sir.
Why?
Because you're not looking at all the different strata, right?
Right.
Like,
Yeah,
yeah,
basically you
smaller
are,
countries you haven't considered
yeah, we
very.
are not that, I mean, that analyst didn't consider the data or the people from the no who are from poor locality, something like that. I mean, basically they didn't do the sampling randomly. Okay, so there is something bias comes into the picture. So there are lots of techniques for this sampling. Okay, one of this I took example of purposive sampling, and you can see that's called another called simple random sampling. Then comes stratified sampling. Then comes systematic sampling. So these all techniques are very helpful in different situations. Okay. Okay, so what are the research things you can explore? So something you can develop some sampling techniques. So you can see there are these are different kind of sampling techniques for different situations. So you can develop some sampling techniques where it's hard to reach some populations. For example, migrant workers, for the migrant workers, and you can work on some adaptive sampling for real-time social media analysis. Okay. So these are just some, I took two examples. There are lots of examples. You can explore more on that. Okay, so the next one is time series analysis. So how it displays what are the real life users actually. So time series analysis, basically what this does. So it's in this actually it's analyzing the data points collected over time to identify the patterns. Okay. So what it does, so basically there are some time. Okay, suppose I'm considering time t. Okay, so in a way you can define yt as a f of t. This is just a function. So what is this basically? Suppose your one of the variable is time t, and you are on the different time you are going to collect the data. Okay, and what is the yt will be, what is the observations at time t1. So this will be y1, this will be y2, this will be y. So basically not y yt1, yt2. Okay, so basically this will constitute your time series. So actually this time series is very helpful in uh, business field, economics field, and all, everywhere actually. So okay, so can you give me one example of this time series part? Can you think? Any example?
Stock market data.
Okay. That's all.
Uh, Rainfall over last 5 years.
Okay. Sales data. Yeah, sales and profits in departmental store. Okay. Basically, you can define. Okay, so this T1 you can take as a 1 day, 2 day, second day, third day, up to let's say for 10 days. Okay, then you can observe sales and profits in a departmental store. Yeah, that is the one of the example of time series data. Another thing you can think about, this stock exchange. That's correct. Then, bank clearings, bank deposits. Okay, all those things. It's so basically key ideas for the different times. This you can say you are collecting the data on in accordance with the occurrence of the different time. So based on this time series data, basically you will identify, okay, so whether what kind of trend is there, whether there is a something called a seasonality or cyclic variations or something called noise. So what is the trend actually? So trend is for this trend. If you will observe the data, so trend is simply we mean what is the tendency of your data for a long period of time. Okay, so for example, you can see, right, so there is upward tendency we can see in data of the population, yes or no, for a long period of time, right, for a long period of time. So you can see upward tendency in terms of population, right, and you can see downward tendency if you notice the data of birth and death rates, some epidemics and all, right. So there is, you can identify a downward tendency for data of epidemics, yes or no, for a long period of time. Are you getting my idea? So basically, see, okay, can you tell me any reason why this? There will be downward tendency if you are observing the data of epidemics and data of births and death rates. Anyone? What are the possible reasons? It's a very simple answer actually. No one? Okay, so basically, it's you can say this is just a result of uh, like, this is just a result of basically in advancement of medical sciences and better medical facilities and all. Okay, so because of this, we can see a downward tendency for a long period of time in this birth and death rates and all. So second thing is something called seasonality. Okay, so this seasonality actually we observe this seasonality we observe for a span of less than a year. Okay, so whenever you are uh, observing a data of less than a year, so that comes under the seasonality. So what does this mean? Okay, so basically I will give you some idea. So basically, okay, you can see if you have and suppose there is some festivals like Diwali, Dasara and all, Christmas and all. Okay, so in those time, okay, in those time basically you can see, so there is you can see in increase of okay, some sales in sales of sorry, in increase of in this departmental store because of Diwali, Dasara and all, yes or no. Also you can see during the summer season there is this sale of umbrellas will pick up very fast in rainy seasons. Okay, in summer season the demand of electric fans it will goes up. Okay, sale of ice creams will increase in summer season or not. So you can see, so these all things comes under the seasonality. So within a span of less than a year you are observing a data of 12 months. And what is the noise or irregular or random components? So this happens which are not in human control. Let's say basically it's beyond the control of human hands. So for example, there is maybe earthquakes, wars, floods, and lots of things. Okay, because of those things, data might affect. Okay, so these are just ideas. So what are the real life uses this stock market someone told? So you can predict the share price movements and weather, also forecasting temperatures and rainfalls. Okay, why it matters? Because it will allow planning for recurring events and anticipating change. So what is the meaning of planning for recurring events? Suppose you are owner of a manufacturing company, and based on your analysis, based on your sales and profits of last date last for a last year or last 2 or 3 years. You can decide, okay, these many products you have to buy, and these are the number of manpower you need, something like that. So you can plan for this. What are the basically research areas for this case? So there is financial time series forecasting. You can go. You can think of climate change impact assessment, then long-term infrastructure demand forecasting. And what are the bodies which will help you in this time series analysis? Actually, is SEBI and NSC research, etc. So these all the bodies using this time series analysis actually. Okay, so anyone, so far it is okay, or you are getting bored, or what? It's fine. Yes, no. Okay, all right. Okay, so if you are getting bored at any time, let me know. We can have some other discussion. Okay, that's not a problem. Okay, so then again, which is the very attractive things for most of you, it's machine learning plus statistics. So what is this actually? So it's using algorithm. Okay, sorry, there is typo. So it's using algorithm to learn patterns from the large data sets. Okay, so this statistics is basically, see, you can see in foundation courses, statistics, mathematics, these all things courses are there, because it creates the foundation for many ML algorithms. So you can logistic regression, Naive Bayes. So to understand the Naive Bayes, you should know, okay, what is the Bayes theorem and all. Okay, to understand the regression, some ML techniques, okay, you should know what is the maximum likelihood estimation. Sort of. Basically, what I'm trying to say, this statistics creates a very important role in ML algorithm. Okay, so I took example this Swiggy delivery time prediction. So you can use multiple regression there. Okay, so what I mean by multiple regression, suppose there is Swiggy delivery time prediction. So Swiggy uses a real time what they use, real time traffic data, then what is the live weather updates and historical delivery records. Okay, to predict the how long your order will take. Okay, whether it will take 30 minutes, whether it will take 40 minutes or 45 minutes or 20 minutes, whatever. Okay, so if you see, so here multiple regression plays an important role, because there are multiple independent variables, multiple factors, multiple features. Okay, so what are those features you can take? They account for distance, this road congestion, and even whether restaurants preparation, speed of the food. And so basically all these, if you consider all these things together, so this will give you the and estimate delivery time. Okay, so what are the real life other uses? So this is just an example. This is not only cases. So in banking, they use this ML to detecting the fraud in real life. Okay. In social media, okay, recommending content based on your past data. In healthcare, they predict disease outbreak from hospital record. Okay, what might be one of the research pathway actually? So basically, you can think of to develop interpretable AI for health diagnostics in rural clinics. Okay, so this rural word is very actually in most of the things we ignore. Most of the time we ignore the rural part actually, but we have to think of it. And another thing, how you can apply ML to optimize government subsidy distributions and all. Okay, so this is just some rough idea about this ML plus statistics. Next one is called design of experiments, called what is short term is DOE. So this what this DOE does actually. So this is the systematic method to determine the relationship between factors which affecting a process and the output. Okay, so one of the example you can take. So this DOE is very famous and very useful in agricultural field actually. So what it does? Okay, anyone? If you know, can you think of how you can apply? Okay, based on this line, systematic method to determine the relationship between factors which affecting a process and output. Can you think of it?
Sir, so a DOE is like you have certain hypothesis that you set up, and uh, you design like how the data has to be like structured.
Mm-hmm.
So I mean, farming experiments normally it'll involve like if you're trying to see if fertilizer is good, for example, then
Correct, correct,
you will have maybe 9 different plots of land, and then in those different plots you'll use the fertilizers in different ways, and then you design the way that you use that so that you can then do hypothesis testing and make a conclusion based on that.
correct, correct. So basically, you can say, so you can do the testing of multiple fertilizers and irrigation levels on the crop plots. Okay. So basically, what's the in general, if you think so, it determine the relationship between the factors. Okay, this fertilizers and irrigation level and the output crop yield. Then it's what it does is basically it's planning experiments to get most information with the minimal resources. Okay, so this involves randomization, replication, blocking, and also this is there are lots of another techniques. It is called short form is CRD, RBD, okay, something Latin square design, LSD, and all randomized block design. So there are a different kind of techniques. Okay, what are the real life uses? Again, this agriculture, you can see. So I have taken most of the example from agriculture. So it's so basically ICSR, this testing multiple fertilizers combination. In industries, actually, this Tata Steel, they use for this for different cooling rates for the stronger steel. And again, in terms of education, NGOs testing variations of training programs and all. So this is basically how it's helpful. Yes, Kritika.
Sir, it's also used in clinical trials, right? Like it will be used a lot.
Yes, 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 you can. So I
Oh,
took just a few examples. That's not.
okay, okay.
Yeah, yeah. So basically, see, if you see the what is the key thing in design of experiments. So basically, how you are going to plan. Basically, I mean the experimental or there will be 3 phases actually for this DOE: planning phase, design phase, and analysis phase. Okay. So in planning phase, what you will do? You will define your problem, and then you will what is your choice of dependent variable. So here, choice of dependent variable will be my uh, crop yield, right? Then selection of factors. So other thing in design phase, what will be number of observations? How will you design? Basically, order of experimentation. What are the methods? And then hypothesis to be tested. And in an analysis phase, third phase, we'll we'll do data collection and processing, and again computation of test statistics, and finally interpretation of result for the experiment. Okay, and in research pathway, again, the design of experiment, you can think about sustainable farming practices. It's again related to agriculture, and DOE, design of experiment for optimizing renewable energy system. So these are the things you can go for this. You can apply this DOE concept and all in this kind of areas. What are the research bodies for this actually? So this ISI, Indian Statistical Institute, IITs, IICs, some central universities are there. So for research bodies actually, I mean, what are the research bodies for overall the things we discussed? And in terms of government, so CSO, Central Statistics Office, NITI Aayog, etc. In industry, you can go for pharma, tech, finance, e-commerce, and funding. In terms of funding, DST, SERB, IC, SSR, and DBT. So these are the research bodies you can apply those things, okay, based on your. So basically, I wanted to give you some idea how to get started. So basically, you can build a strong. You have to build your strong fundamentals. Okay. So what I mean by strong fundamental, basically, okay. So I will take very simple example. Sometimes people are not able to identify, okay, so this is the categorical variable and this is a numerical variable. Okay, so sometimes it and categorical variable you can label. Okay, suppose there is a category of female and you will label as a 1 and a male as a 0. Suppose there is 2 categories, you have data of something like this: 1010 110, something like that, and there is a, let's say, age of these persons. Okay, so what people does, sometimes they took the average of this column. So which doesn't make any sense, right? Okay, this is meaningless. Okay, so you have to build a very strong fundamentals. So along with what kind of data is this, what is the descriptive statistics mean, what is the inferential statistics means. Okay, and I would suggest you to start learning R or Python. So R is very popular for core, I mean, in terms of statistics, and Python is no comment on Python. Actually, Python nowadays plays a very important role. Even you can start with very simple things. Excel also. So in Excel sheet you can do lots of regression techniques. Okay, without going in R or Python. Maybe you have seen there is something called SPSS. Okay, so SPSS for statistics, very famous. And basically what you can do, you can you have to build a strong fundamentals, and then you can start working with some open data sets. So there are some government data set you can find out from data.gov.in, and Kaggle is always famous for this. So you can take some data and try to apply some basic linear regression, at least try it out the house price prediction or something like this. Okay, and I would suggest to attend some workshop and join some research collaborations. Okay, start with at least small projects. Okay, try to collect some data and try to, okay, you can define, for example, house price prediction. Okay, so you can define, okay, how I can predict the house price. For the house price prediction, what will be my independent features, and then what will be noise, and then this will be your model, and based on past data, you, okay, you basically you define your model something like this. Okay, and then for example, and suppose I gave you some value for x1 and some value of x2, then you will be able to predict, okay, so for this value of x1, I mean, okay, so for example, suppose I say, okay, there is a house in which, in that house there is there is 4 bedrooms, and the area of house is, let's say, 5,000 square feet, something like that. Then you will be able to predict, okay, this will be the price of the house, something like that. So you can at least start with the very open data set that will give you some idea. Okay. What is the very basically final conclusion? So again, the data is the just a raw story of the world, and statistics is, it will tell you how you understand and shape that story. Okay, that's the statistics. So first question from my side, if you had to apply statistics in one thing in your daily life, what would it be? So I would like to hear from all of you. What would it would be?
Sir, average calories.
Okay, great. Just one person you can think of?
So someone had mentioned productivity like earlier in the chat when we were
Okay.
talking about using stats. Yeah, I think that would be a very cool thing to like try to
Okay.
figure out
Okay.
productivity levels.
Okay, great. What about others? Maybe to know traffic in the city like Hyderabad. Okay, I'm planning to do something. I would like to visit for the team to know odds of success and failure. Okay, okay. So some distributions coming into the picture. Yes, that's all. Okay, so the
Maybe to find equilibrium between less workload and high paycheck.
high
Paycheck.
Okay. Okay. All right. Great. Yeah. At least you are thinking on that. Okay. So that's all from my side. So Samibrata has sent some questions. So I would like to give the answers of those questions. Okay. So, okay. So first of all, uh, did you learn something, or was it okay, or was it too boring?
It was great, sir.
Yes. Okay. I was just trying to give you the idea. If you want anything in detail, let's say, for example, hypothesis testing itself, so we can have a deep discussion on that, or some central limit theorem, or we can have a deep discussion on that. So that will be discussion on a single topic. Okay. Anyway, so there are some questions I got, so I would like to answer for those questions. Okay, so first question was, how can beginners like us start contributing to real world research project involving statistics? Again, so basically I would say you can start with small and with very small and local things. So what I mean by local things, so basically you can volunteer in projects at your if suppose you are in any offline universities, or you can contact to some NGOs, or if possible any startups, and also you can take some data. Okay, even if you are doing any internship under a professor and all, okay, so you can take data and you can learn, okay, how to clean, how to do pre-processing of data, how to analyzing the any survey data. Okay, also first of all, again I took this example, right? You can go with this public data set, so this Kaggle or this Indian government data set, and you can start practicing. Okay, and then okay, for example, you can analyze rainfall and crop yield trends. Okay, similar, I took the example of house price prediction, right? You can think of this again. You can analyze rainfall and crop yield, so at least start with the very open data set, and then once you will get to know, okay, so these all are the steps you had applied in open data set for a small data set. Then when you will get real life data set, you have to think for the pre-processing of data set. I mean, you have to first of all you have to make the data set very clean for your study. Okay, so the next question was, what tools or domains do you recommend focusing on early in our journey to build a strong foundation applied statistics? Again, I will say start with Excel, Google Sheet. Even Excel and Google Sheet are very, very useful for a small data set. Then you can go for R and Python. So in Python, you know, this pandas, NumPy, lots of stats models, SciPy, and for visualization tool, you can explore, Tableau, Power BI, and all. Okay, so basically, and okay, so if how you, what will be good starting? So start with your domain of interest. Domain of interest means take the data in which you are too much interested. Let's say take the data of sports. Okay, you can take the data of sports if you are interested in sports. Then you can take data of healthcare, or if you are interested in social media things, so take the data of social media. So there are lots of data available on Kaggle. Try it out. Okay, and you can build one real project as per your interest. Okay, so the next question was to explain how we can improve our understanding and implement stats in our real life. Okay, so first of all, again I will say track your daily habits. Okay, I took the example of that restaurant selection, right? So how you select the restaurants. Okay, this restaurants we are planning to go for dinner. Okay, so for what will be your first thing? You will see, okay, average rating, yes or no? So what this average rating, this comes under the descriptive statistics. So try it out in your daily life, right? So for example, that Swiggy delivery time prediction, you can think of, okay, this might be way they are doing this prediction or something like that. Okay, then movie recommendation. Okay, and then also you can see about your travel things. So travel things, I mean, you can check, okay, this is the averages and standard deviation, to you can to predict, okay, this is the travel times, okay, distance from point A to point B. Okay, based on past data you can predict your travel time. So basically what I'm trying to say, try to apply in daily real life. So also whenever you see any formula, okay, do not consider just a formula, okay, 1 upon n summation x. I mean, this will help you anyway, that's not a problem. The thing is, try to think about, okay, why this is summation of xi okay, in variance we are using 1 upon n minus 1 summation of xi minus x bar square. Okay, so just think, why this summation of xi minus x bar whole square? Why not I can take some summation of absolute difference of x bar divided by n minus 1? Why not summation xi minus x bar divided by n? What is the reason behind taking not taking this, not taking this? So there is reason behind every formula. Okay, so what is the key thing? Do not learn anything blindly. Okay. So next question was how could we leverage the benefits of statistics in this AI bubble? Again, so this AI or ML models are, statistics. Basically, these in statistics are at scale point. Basically, you can see regression things, classification, probability distribution. These are playing very important role in this AI and ML part. And you should understand the statistics, which will help you to how to interpret the AI outputs. Okay, how to spot the biases, how to avoid the blind trust in any model, anything. Okay, basically, for example, very simple example. Okay, what about spam filter? You have seen, right? Spam filter is just a probability model. Yes or no?
Yes, sir, correct.
Correct. So the next question was how exactly are things predicted using statistics? Okay, so this is something I would like to hear from you guys. How exactly are the things predicted using statistics? What are the steps? Can you tell me? Means how exactly the things are predicted using statistics?
So then for like anything,
Anything,
firstly,
anything. That is the one of the general questions. So how? Let me write the question. How exactly are things predicted using statistics? General steps.
so first to find out the data that you're using,
Correct.
then to like go through the data, clean it, make sure that it's actually usable,
Mhm.
process it into a form where you can actually use it to model something,
Yeah.
understand, do EDA on it so that you're
Correct. Correct.
understanding like what is the data, like what is
So
the structure.
basically, correct. So if I would like to summarize in few steps, so basically, I will try to go with historical data. Correct. Plus, I will try to identify the patterns. Yes or no? And then, based on this, I will make a model. Yes or no? And
Yes.
then there will be probability based forecast. That's all. This is the key thing we are doing. Yes or no? Okay. So there was next question was how is statistics relevant for investors? So again, so this portfolio optimization, these things uses mean variance analysis. Okay, there is something called mean variance analysis. Okay, so the portfolio optimization things uses this mean variance analysis. Okay, and in for the investors you have to check the risk assessment also, right? So the thing assessment that uses there is something called where. Okay, so where is value at risk. Okay, and what is the standard deviation of returns and all. Okay, so this is the, so basically investor use also they use the hypothesis testing to check if a stock strategy outperforms the market or. Okay, so these are the way portfolio optimization, risk assessment and all. Next question was how statistical analysis can be used in core engineering like mechanical. Okay, so there is very good question. So there is something called statistical quality control. Okay, so this statistical quality control plays a very important role in all the field actually. So what it does actually, so in quality control, we are checking the product quality. We are doing two things actually in quality control part. Let me go here. Let me erase this. Okay, so in quality control, okay, by this quality control, there are two things. Okay, product quality and then process quality. Okay, basically product control and process control. Okay, so okay, anyone can you guess something about this process control and product control? Let me write here. If can you guess something? So quality control. How will you control the quality? Process control. Let me write here, and then product control.
Sir, so I guess it would be something like process control will be making sure that like the process is actually happening efficiently. So
Efficiently, yeah,
in
yeah.
manufacturing, if the machines are working
Correct,
properly,
correct. So basically, you'd like to check what is the whether the proportion of defective items actually, the proportion of defective items in the whatever the product you have manufactured. Okay, manufactured product is it shouldn't be too large. Okay, then there is a quality in process. What is the product control? Product control actually, so this is something you are controlling the quality of the product. So by basically you are doing the critical examination as different steps. Okay, so in quality control actually, to check to ensure the quality of product and process, so there is four important things. Okay, so what are those four important things? So there's those four important things called first one is called you have to be ensure of quality of materials, and then you have to check quality of manpower, and then quality of machines, and then quality of management. Okay, actually these four M's, materials, manpower, machines, management, plays very important role. So in field of mechanical engineering, suppose there is any product or any bolt you are manufacturing, you have to take care of these things. Okay, so next question is how statistics works in real life. I mean, how to hear the music of statistics? That's one of the question from your side. Basically, it's in the pattern. So basically you are observing the rhythm in numbers. For example, there is cricket players batting average over time. It's like you are hearing them basically what's the melody of his performance. Okay, so basically it's you have to observe, you have to be in patterns always. Okay, once you learn to visualize the data, you will start how to hear the patterns, how to hear the music of statistics. Okay, then someone says suggest some good books for better understanding stats for DS degree. So there are lots of books actually. Yes, Ganesh.
Sir, you complete this one, sir. After
Okay,
this,
all right. Yeah, yeah. There are lots of books actually if you want to check. So for basic probability, and also there is called a first course in probability by Sheldon Ambrose. And if you want to explore in inference part, so there is a book, I forgot the name actually. Another book is Practical Statistics for a Data Scientist, and there is one more book, The Art of Statistics. So there are lots of books. There is one more book if you want to know the history of statistics. So there is called Lady Testing Tea. This is just a theory. Theory is not doesn't involve any formula, but theory behind everything about statistics. Yes, please go ahead.
yes, sir. Sir, so this is just a bit philosophical kind of question.
Hmm.
So with statistics, can we unlock the many intricacies of this universe with appropriate statistical process? Like,
Sorry.
what are the limits of statistics? How beyond what we cannot go and experiment this universe?
Okay. Okay. So what's your idea on this? First of all, I would like to hear from.
So
Yeah.
as of now, I was thinking that if we have enough parameters to work on, then using available methods, we can unlock the hidden force that operates this human society, like that kind
Okay.
of thing.
Okay.
Yeah, this was my idea as still now. Sir.
See, if you talk about the limits, actually, so it's okay. If you are saying you cannot go beyond the universe, so these are two things, right? First of all, this is a philosophical and technical point. Okay, so basically, if you say first of all, you need to understand what is the nature of statistical limits. Okay, so what is the limit actually? See, how will you do statistics? So basically, statistics starts from basically from collecting data, you are summarizing and you are making inferences and all, right? Correct.
Yes, sir. Yes.
Basically, it will fail when there is no data exist. Correct.
Okay.
Okay. Something there is okay, there is something guarantee of 100% accuracy. That statistics is not. Statistics, you are making decisions under uncertainty, right?
Okay.
So basically, if you talk about universe, so there is two things of universe. Sometimes you are saying population as a universe. So basically, universe is a complete set of items you are interested in. Okay, so basically, okay. For example, if you want to do a study, go for studying all farmers in India, then what will be your universe? Your statistical universe will be all farmers throughout the India, right?
Yes, all farmers
All
population.
farmers. So what you can do, you can take a sample from it. You cannot go beyond it, right, without making any other assumptions. Okay, so basically when it fails, whenever no data, no inference. Okay, and
Okay.
some extrapolation, some extrapolation danger is there. Okay, what is the meaning? Suppose you are going to predict some outside observed range beyond the universe. So for example, if you have data for humans aged which is aged from, let's say, 10 to 80. Okay, and your regression might predict a 200-year-old person earns 50 lakh per a month. It's meaningless, right? Because that it's not exist in the universe. Are you getting my point?
Yeah, yeah, yes.
Okay, yeah.
Yeah, actually, the reason why I asked this was I am currently studying about human population dynamics, like
Oh,
how
okay.
different population changes at particular times. So, what is the thing that hidden force that motivates these kind of changes? So
Actually,
that's
that
what I
for
asked.
that this hidden things you have to identify, right? This latent, maybe
Latter, yeah,
latent variables and all, right? You have to take care of those things also, right? So you have
yeah.
to, yeah, yeah, yeah.
Okay, sir. Okay.
Yeah. So next question was statistics as a business strategy, actually. So business strategy is very, very helpful. This again, this time series analysis and statistical quality control is going to play a very, very important role. So basically, you can say, so for example, this Netflix A/B testing. So for this thumbnails to, I mean, for improving the clicks, actually. So in business, actually, it's very, very helpful, this statistical quality control. I mean, you can define, if you have any business, you can define how to where it went, 4Ms where I wrote, yeah. So this, what should be quality of materials, what should be the quality of manpower and quality of machines, and there should be quality of management and all. Okay, so these are four important things you have to take care of in business things also. And there was one question, use of hypothesis testing, central limit theorem and joint distribution in machine learning. So again, we discuss hypothesis testing. It will help you to decide if a model is significant or not. So what I mean by model is significant is that you will test for, let's say, there is a new medicine. You check whether this new medicine is superior than the existing ones or not, or basically there is a claim made by a owner. You are going to test whether that claim holds true or not. The central limit theorem helps in basically estimating model performance from your sample data. If your sample data is large, then on an average, basically that will converge to a normal distribution. So suppose you have collected data from any discrete distribution. Okay, the what is the role of central limit theorem? So if the data size is sufficiently large, so the distribution of that x bar minus mu divided by sigma square root by n, it will follow normal 0, 1. So then it will be very easy to interpret the result. Regarding the joint distribution in machine learning, again, so this multiple, you need to understand the joint distribution part very, very carefully. So because this will help you to understand the multiple variables together. Okay. So because if you are able to understand the multiple variables together, then it will help you to understand the feature correlation in data set. Okay, and this again you will see the GMM Gaussian mixer model. To get this idea, you need to understand this joint distribution and all. Okay, so there was one more question: statistics in astrophysics. Okay, so what it does? So this basically how it's applicable. It detects the exoplanets. So what are so your exoplanets from light curve fluctuation? So it will detect those things. And what is the advantage? Actually, many astrophysics data set are noisy. So you need a strong statistical ground to help to extract the signal from those choices. Okay. Sorry. Just give me a minute. Okay, all right. So there was again there was one more question. What is the relevance of statistical theory when assumptions fail? Actually, so in reality, what are the assumptions? Basically, we are making assumptions of data set. For the data set, it should be a normality, independence. So these are just basically simplifications. So what's the solution for this? You use less sensitive to assumption violations. Okay. I mean, we use some robust statistics, and we can do basically we can apply resampling methods if we don't want to if the assumption fails. So one of the technique for resampling methods called bootstrapping, and then we can model the deviation. Okay, and instead of ignoring those kind of things. So for example, financial returns are not normally distributed. You can see they are heavily tail distribution. So normal they are not financial returns. They are not normally distributed. Okay, normally it should be bell shaped because they are heavily tailed, something like this or something like this. Okay, so I think Sambrata, I have covered the questions if not wrong. Okay, so I hope you got something. Okay, so that's all from my side. So I'm okay for any question. So first of all, did you get something, or is what was it boring? Okay, be honest. That's not a problem.
No, sir, it was very interesting. And what I do, I can share. When I learn or study statistics, I basically I post a question on ChatGPT and ask it that give me a real life example of this. So basically, it helps me to develop the real life scenario of that particular statistics. So
Okay,
that's how.
that's the better. So this chat GPT and all, it's very helpful. So you should use it actually. Okay, so okay, suppose you want to practice for any problem. So suppose for example a hypothesis testing question. Okay, so you can paste one question, and then you can ask give me 10 similar questions with different numbers or with the same difficulty level. ChatGPT will give you 10 different questions. You can practice those questions. Okay, so then by this you will get some mastery on that particular topics. Okay, so you can use, that's not a problem. That's a good idea, I think. Okay, anybody, anything else?
Sir, I got a question. In regression, most of the time we try optimizing the MSE, but in classical regression, we when we are following Gauss-Markov model, we generally come up with assumptions like homoscedasticity,
Mhm.
normality of errors, and all.
Mm.
So, but even if when we don't have such data, we are still trying to optimize the MSE. So, what exactly I'm gaining if the data is following the Gauss-Markov assumptions?
No, no. Can you come again?
So basically, in the scenarios where we don't have a data set which follows those assumptions, like it is not, suppose it is not homoscedastic, or the errors are not normally distributed. In those scenarios, I'm also trying, similarly trying to optimize the MSE, right? But what exactly I'm gaining if the data is actually following the Gauss-Markov model?
Okay, see, first of all, okay, what are the things you are doing in classical regression? Then
So,
you are trying to go for the MSc, right?
hmm,
Basically, right? So in Gauss Markov, and see, there is OLS also, correct?
yes.
Basically, I mean, if you
So
see the
basically,
agents,
in OLS only, I'm trying to optimize the MSE, right?
correct, correct, correct. Basically, you are using that least square things, right? Ordinary least
Exactly.
square thing. Okay, so you okay? What are the certain assumptions? Basically, you can see the linearity and there shouldn't be perfect multi-collinearity and all, right? So
Homoscedasticity.
homoscedasticity, right? And also, if you the assumptions are not fulfilled, basically, so what you lose basically if the okay suppose if only normality phase, right?
Hmm.
Then ordinary okay, so something you have seen the blue, right? Best linear unbiased estimator,
Yes.
correct? So basically, in that case, that OLS will also still exist, but the hypothesis testing test you are doing, let's say T or F, that may not be valid for if you have a small sample size, correct? Okay. If
Okay.
the heteroscedasticity exists, then your OLS is is unbiased, right? But see that variance estimates are wrong because there is heteroscedasticity. There is no homoscedasticity, right?
Hmm.
And again for the autocorrelation and all. So what is the basically you can still gain? You can get the point estimates because see from the OLS estimator you might still be getting the unbiased things, right? Okay.
Hmm.
Basically, OLS gives you the coefficients that are very easy to explain. Okay.
So basically, if it doesn't follow the assumptions, I'm
Hmm.
not getting as good as.
As good as correct. So those are the assumptions which will give you the key things.
Okay.
Yeah.
Okay. Cool.
So if you want, we can have a detailed discussion on this. I mean, in any of the topic, a deep discussion rather than. So today's session, I just thought to give you a general idea for some topics. Okay. So if you guys want, we can have detailed things in deep discussion.
So
Sure,
can
sir.
you share your LinkedIn?
LinkedIn things here. I need to check. Okay, I will share with Sambibrata. He will.
Yeah.
Yeah.
Sir, I guess we have a couple of questions in chat as well.
Okay, Jet. Let me see. Give me 2 minutes. Actually,
Yeah,
office is
sure.
going to be closed. I have to give me 2 minutes. Huh?
Yeah, sure, sure.
which question? I think this. What are the limits and challenges of stats? There are some.
That one, sir, can stats lie or fake the reality?
Okay, okay. So I think that the previous one limits and all we discussed, right? If the, I mean, I took that example. If there is no data, then you cannot. And I took that example of, sorry, example of you took a data of people from age 10 to 80, right? Then and your model is predicting there is a person who of 200 years old and they are earning 50 lakh per annum, then that is something, not a good thing. Okay, so that those kind of things are basically limits and all. So if you want, if you are saying whether the stats lie or fake the reality, so basically see. Okay, so I took one example, that purposive sampling. In that case, what we are doing? Can you help? And can you tell me?
Sorry, sir. Can you come up again?
I took one example of purposive sampling, right?
Mhm.
So what in that case, what we were doing?
So we are just sampling based on
We are taking the data from the rich locality only, correct?
locality, exactly.
So basically, see the things, these stats lie or fake the reality. So in that case, so you cannot say the standard of living has been increased in Delhi, right? That's not a reality. Are you
So,
getting? So basically,
based
it's how you collect, process, and present the data that can mislead or that can give you the good interpretation also. Are you getting my point, right? So
yes, so based on the tools we are using, it could.
yeah, what is the tool you are using? How did you suppose you did collected the data only from the rich locality? Then it will give you the another things, right? And then the tool. Okay, so suppose so you can deliberately focus for the wrong sampling units, right, for your study. So that will give you some different situations, right? And there will be some sampling biases and all based on this. So there is something called see, suppose for example there is some medicine, that medicine works for 80% of the patients, right? But it may be it tested only on healthy people and all, right? Again, this is not a reality, correct? I mean, you didn't test the that medicine on elder people or children. You just simply tested on the healthy people, and your conclusion is medicine will work for 80% of 80% of the patients, right? Kind of things. Okay. So these are different example.
Sir, I get it that data generally, I mean, stats generally don't lie, but the choice of tools can.
Also,
But unknowingly, if someone tampers with the data and the thing data poisoning where comes into picture, so how to mitigate that situations? How we can
actually,
check sanity?
there is, if you are performing anything, there is two kind of errors. First one is chance error. Second one is assignable. What is assignable? Assignable means you can identify and you have to try to minimize those errors. So identify means, let's say, okay, I took the example of that quality control. You have to identify machines shouldn't be too much old or defective machines, right? Correct. One thing, right? Machines shouldn't be, and the manpower. Okay, so the manpower. Okay, what are the employees or there are persons? Okay, or there should be a skilled person so that you can avoid those. You can identify the errors, right? Those possible ways of errors. Are you getting my point?
Yep.
Okay. So these kind of things you can try it out, and Sukanya message in the chat. So that randomness also is one of the part. And what are the chance errors? So suppose you are manufacturing any product and due to slight vibration of the machine, this is something, it's a random, right? Right? Slight
Uncontrollable
and
by him.
okay, voltage fluctuation and some change in temperature. These are the random error, right? Okay. So we have to minimize the something assignable which are possible, right? Okay, so you can give employed skilled person and trained person, right? You can take raw materials of good quality, something like that. Okay.
Oh.
Yeah.
Um,
Okay. All right then. Anything else?
any more question, guys?
I think they got bored. Everyone is leaving the call.
Okay. Thank you, Prashant sir, for
Thank you.
the mindful event and the valuable insight and helping us with connect the dots to draw real world statistic situation.
Thank
Also,
you.
thank you to all the participants for your attention, question, active participation. Ultimately, it's you curious and your curiosity which keeps the community growing. Anytime you need to have your query solved, feel free to ask in our G space. Anything regarding your coursework or projects or something regarding these sessions, uh, just write it over there. We'll try to convey it to this to Prashant sir. And also a big shout out to all our co-members, Shukanna, Srovana, Sinu, Ritik, without whom it wouldn't have been possible, and Nilgiri House as well. Also, okay, that's from my
Okay. Thanks all. Bye.
Thank you, sir.
Thank you.
Hoping you to see you for more talks.
Yeah, all right. Only you guys are not getting bored. I'm okay with that. That's not problem. Okay. Okay. Thanks, sir. Bye.
Thank you.
Thank you, sir.
Okay.
And thank you, Samir brother, too. Actually, it was you who worked.
Welcome.
Oh,
Good
okay. All
night,
right. Good
everyone.
night.
Good night, sir.
Bye. Bye. Thanks.
Yeah.